Okay, today in class we went ahead and started with section 1.3 called order of operations, and what we're going to do is we're going to simplify expressions, evaluate algebraic expressions using the order of operations, and then we're going to evaluate algebraic expressions using substitution. So a numerical expression, we're just going to first talk about it. It's an expression with numbers, operations, and grouping symbols. So we've got numbers, operations meaning add, subtract, multiply, and divide, and then grouping symbols, you have a couple that we'll use. First you'll see parentheses, you might see brackets, and then eventually we're going to see those are absolute value symbols. An algebraic expression is any expression involving numbers and or variables and operations. So the difference between the two is now we include variables or unknowns, and usually we represent our own unknowns with alphabetical letters, and typically we use X and Y. We use those two a lot to represent our unknowns. Okay, simplify is to use order of operations to make the expression smaller, and I use the terminology combine like terms. So I first of all wrote, hey, we have X, and if I add 4, can we add those two? We said no, because they are not like terms. This is an unknown number and this is 4. So then I said, well, if we can't add those, if I add an X to the 4, can we now add those? Yeah, we can. That becomes 5X. And then I said, well, what if we change that X to an X squared? Are those like terms? And the answer is no. That power right there and the power on the other one, which is a 1, are not like, and they're not exactly the same, so they do not represent quantities that are the same. So then I said, well, what if we add a Y on here, a 4xy and an X? They both have an X. And we talked about how they both have to have the same variables, which these two do not, and they also have to have the same power on the variables to be like terms. And we'll do a lot more of this in the next section, not so much this section. Okay, so on example 1, it's asking us to write an algebraic expression. So our first one, or for each of our situations. So the first one says 12 is increased. So we say increased is important to know. Increased means you're going to add by the quotient. And we have a lot of you guys say that the quotient is the answer to a division problem. So we're going to divide of a number we don't know and 6. So we first are going to write 12 is increased by the quotient. So we're going to divide or have a fraction of a number, we don't know the number, I'm going to choose X, you could choose anything, and 6. And there we go, there's our expression. On B it says the sum of a number cubed. So sum is important. Sum means we're going to add up several things. So we have the sum of a number cubed and another number. So we have a sum of a number cubed. I'm going to choose X, we could use whatever variable we want, a number cubed. So we're going to sum means we're going to add a number cubed and another number, so choose Y. And I didn't mean to do this, but it's in here, so we'll go ahead and cover it. When it says is less than, that means we're going to use, if you remember the alligator symbols you used before, and we talked about these two choices here, and in class we decided it was definitely this one. So it's the less than symbol, not the greater than. So if we add those two, it has to be less than 5. Okay, then we went on to talk about the order of operations. I actually had, in class we did an activity that involved doing the order of operations, and we talked about how there's order in all things, and we have to have specific orders to do things, or there's certain things don't turn out. We talked about baking cookies and about the order of things. We have to actually mix the ingredients before we put them together and roll or put them out onto a cookie sheet and then put them in the oven. There's a specific order, otherwise the cookies don't turn out. We can't mix them all together and forget the egg, and then after they've been baked try to put the egg back in. That won't work. So just like cooking has an order, so does math, and we use this. I use this, please excuse my dear Aunt Sally. Some people say PEMDAS, and others made up their own that they remember, and some were pretty funny that they were sharing with us, but I always use please excuse my dear Aunt Sally. And the P in the please excuse my dear Aunt Sally represents your parentheses, or they can be brackets or absolute value. So we got our parentheses or brackets, or absolute values. Our next, our E in the sane represents our exponents, and we also call these powers. So if you have something like this squared, you're going to do whatever in the parenthesis first and then do the exponent. I have the M and the D together because it doesn't matter which one you do first, or I should say it does matter which one you do first. It's whatever comes first, and I always talk about from left to right. We're going to read it from left to right and do whatever occurs first. And then we also have the A and the S group together, the addition and the subtraction, because again that is whatever comes first. So if there happens to be a subtraction before the addition, you'll do the subtraction first. And you could also say that is from left to right. Okay, on example 2, we're going to evaluate each expression. And I'm going to make you do this the long way. I know it's kind of tedious, but I think if we do it the long way, you're going to more likely come up with the right answer. So we're going to look at this and determine what we do first. We've got a multiplication, so we're going to do that first. So I go 3 minus 5 plus 2 times 7 is 14. And then I've got addition and subtraction. We did those at the same time. We go from left to right, so I'm going to do the 3 minus 5 first to get negative 2. And add 14 for a total of 12. On our second problem, you guys think, some of you call it a rainbow, but you think you need to distribute first. That is not the case. We only do that when we can't actually simplify the inside the parentheses. So since we can actually simplify that, 12 divided by 4, we do it first. So the 6 and 5 we leave alone. I'm going to go ahead and drop the parentheses. When I drop them, it means I'm going to multiply. So 12 divided by 4 gives us 3. And then here I see I'm going to do that multiplication first. So I have 15, and then I add those two together to get 21. Okay, started out easy. I'm getting complicated really quickly. So again, you always want to start with that parentheses. Please excuse my dear Aunt Sally, and we'll do that 8 minus 3 first. And 8 minus 3 is 5. And I do not drop the parentheses on this one because there is the exponent. So that then tells me I have to do the exponent next, and I take a 5 squared, which is 5 times 5, and I have 25. Now I can actually drop the parenthesis because there is no exponent, and there's nothing left to do. And from here I have a multiplication, which will occur before the subtraction, so I take 2 times 25 is 50, and then I subtract those to get negative 46. On our last one, I made this really complicated. We're going to go ahead and start inside the parenthesis that's inside the bracket. So we have 1 plus 2, and 4 minus 5 is negative 1. We're going to still work inside that bracket, and we're going to take this negative 1 and square it because it has an exponent. So negative 1 squared is 1. And I can drop the parentheses now and put a multiplication. So I'm still working inside those brackets, and I have a 1 plus, we're going to do that multiplication, 2 times 1 is 2, and we'll still work on that bracket, 1 minus 2, then inside the bracket you have 1 plus 2 is 3, and I'm now going to finally take care of that exponent. So I have 3 cubed, which is 3 times 3 times 3, and that's 27. I can drop the bracket since there's nothing left to do, and when I drop it I put a multiplication. And now I'm going to do that multiplication before the subtraction, so I have 1 minus 54. I subtract those to get negative 53. Okay, on our last example, we're going to evaluate each expression. And when you see evaluate each expression and you see variables, we look to see if there are numbers for those variables. In this case, there are, so we get to use what's known as substitution. So we'll go ahead and substitute the negative 2 in for the A. B here is 5, so minus B with minus 5, plus C, and C is 6. And we'll do our order of operations. We'll do subtraction because it occurs first. You have a negative 2 minus 5 is negative 7. Plus 6, and we combine those to get a negative 1. On B, because there's an exponent, I'm going to use a parenthesis. So I have A, which is negative 2, we're going to square it, minus 2 times B, and B is 5. And I'm going to do that exponent first. Negative 2 squared is negative 2 times negative 2 is 4. And I can actually do this multiplication at the same time. So I'm going to take that 2 minus 5 is 10. And we go 4 minus 10 gives us negative 6 for our solution or our answer. Alright, that should help you with your assignment 1-3, Simplifying Expressions in Order of Operations worksheet. Good luck.